background in research and automation. My co-founder and the CTO and chief architect at AUAR is Gilles Retsin. He's quite a well-known architectural design practitioner. And elsewhere in our leadership team is Bridget Hipwell, who's our COO, who ran B2B commercial success at a couple of unicorns prior to joining AUAR in 2023. And then Jordi Dominguez is our fractional CFO. He's a two-time exited founder in fintech and ex-HSBC. We're currently a team of now 20 people, mainly based in London. And we are a mix of different types of people, but our core team is all architects that have specialized in automation in some way, whether that's in robotics, in software development, or in operational capacity around hardware deployment. And then we have another side of our business that's really focused on product. So we have a team of architects, structural timber engineers, and computational designers. And we're working on one of the biggest problems that we see in the world, which is the lack of housing, where we see a huge housing shortage across the markets that we're currently operating in, which are in the US, the UK, and across primarily Northwestern Europe. And we know that across the world, there's 2 billion new homes needed globally. And right now, that total housing shortage just in the markets that we're working in is about 230 billion a year. But when we look at how homes are currently being produced, there's three key problems. One is that there's a lack of skilled labor, a very high labor cost for labor that's available, and also a lack of automation across the industry as well. And what that results in is, known problems around CO2 emissions in residential construction, but more broadly, the problem around the social sustainability in terms of societal impact, societal health and well-being, and the impact that this housing shortage has. And then if we look at solutions that have been kind of big promises to the industry, but have failed and have had billions and billions of pounds or dollars invested in them, we can look to the large modular centralized factory as a model that we're directly positioning ourselves against. So the examples that you can see on the left-hand side of this slide are some of which from the UK, like Ilka Homes, which shut down May or March of last year with over 1,000 jobs lost in the north of England, or Top Hat, also a very large company here in the UK, which is now being shut down, or Vive, a prop tech startup that's received over 600 million in funding. And another example, such as Legal & General in the UK, which shut down its capacity in terms of large modular homes in the north of England. And the primary problem really with these kinds of approaches where you have a large modular factory is that they have a myriad of reasons for failure, but the ones that we've identified as some of the biggest problems are that they have a very, very high capital expenditure attached to those factories. They cost a lot to set up, and they also cost a lot to run. And then if you look at the outcomes from these factories, you see zero cost savings in comparison to traditional methods. And part of the reason why this is problematic is because the business model for these factories requires a very standardized pipeline to be run through them, but also a continuous pipeline in order to meet the needs of those OpEx and CapEx overheads. And this is obviously in a kind of direct contrast to the construction industry, which is cyclical and in a way very agile already in that it adapts to changes in supply and demand. And then if you look at the need for that continuous pipeline and ultimately a massive amount of standardization, those factories are really not able to adapt to local planning and design requirements, meaning they need very large sites in order to deliver homes, and they can't really be localized to the, normal eccentricities that come with delivering homes on different kinds of sites. And AUAR has directly confronted these problems by essentially offering a really enormous cost benefit over a large centralized modular factory, where if we ask our customers to spend £5 million in mobilizing our solution, you can produce over 10,000 homes for 125 million return on that investment, which is quite significant when you compare against the zero cost savings that you see in a modular factory. So these things all have come together for us in a model that we think is very promising for housing construction. And this is a great kind of image that explains what we mean. So I'll go into these aspects of our business in more detail, but essentially we've developed a software approach that powers a robotic microfactory that can be deployed in small infill factories or in larger factories, or can be deployed directly on sites, allowing our customers to be able to adapt the financial needs of their business to the way that they develop and build, which we think is a really agile way of delivering homes in relationship to the more normative ways and much more in line with how the industry operates. So our software and hardware solution is really a full value chain automation solution. We have a software platform called Master Builder, which is a cloud-based platform for design to manufacture of timber homes that then creates the manufacturing data for our robotic microfactories, which is a plug-and-play microfactory, and rented to our customers in a kind of no capex business model where they essentially pay us a per square meter or per square feet fee in order to operate those microfactories, and has a very low OpEx. And I can go a little bit more in detail about exactly what that means. And the result of that is that our customers are able to use the backbone of all of this, which is our approach to timber frame construction, in order to deliver really low energy or net zero homes that are also affordable and kind of aggressively below market cost. So I'm just going to show you what Master Builder looks like. So Master Builder, currently we're the internal users of Master Builder, and essentially Master Builder is has a couple of parameters that feed into it. One is our building system approach to timber frame construction, which you can see some of those defaults being set there. And then it also takes in supply chain information from our customer supply chain to set a pricing template. And then it can be powered through this pricing template to be adapted to any kind of costing that's needed, and can be deployed into industry standard software such as Revit, for example, here, where essentially you take a design from an architect or a home builder with very like baseline information, like minimal sizing that's been done. You can use Master Builder to then essentially have it tell you where in that design are there kind of errors in terms of making this data that can be used to manufacture using our hardware. And so, for example, here, Master Builder is telling the user that essentially one of the openings is too close to its neighbor, and you need to be able to adapt the design in order to make it into manufacturing data. We're on the moment pretty close to automating this optimization in real time and creating a list of optimizations that have happened after after that's occurred. And then essentially what it's doing now is creating that manufacturing data in about 5 seconds. So you can see here the timber frame is produced pretty much automatically, and it uses structural constraints as well as building code regulations for timber frame construction to be able to create that information. And you can see here the data that it produces in line with the building code assigned to it, the pricing template assigned to it in regards to the supply chain, as well as the structural and design parameters involved. And then that gets pulled back into Master Builder, where you can see there's a kind of product library of existing designs that we've been working on, and essentially creates that project, and it can exist forever in Master Builder as a product that can be deployed with a kind of full costing, full bill of materials, building quantities down to the nail for that specific project. So you can kind of see that scanning through there. And then you can go and get those building quantities down to the individual elements that are being created for the manufacturing data. And then you can scan into that on an even more granular level through a part of our microservices in Master Builder called Wall Builder. We can go in and adapt the design even more specifically to individual walls. And I'll talk a little bit more about how we've used Wall Builder to start building an AI-ready platform later on in the presentation. And this is all with real costings in relationship to the supply chain for our customers as well, so they can see that in real time. And then importantly, what is the link here to the manufacturing is that this is all pure manufacturing data already. And so it streamlines itself directly to our robotic platform as well, which is going to just show you in a minute the manufacturing data that it creates. which is all code for the robot to operate and build that timber frame. And then when you go to the microfactory, so this is a microfactory that we've had operational in Belgium since January 2024. It was actually upgraded in September to this version, but it was operational prior to that. And what's unique about this is that typically you would have multiple different production lines in a facility producing timber frame. For walls, you'd have a different production line for floors, you'd have a different production line for roof cassettes or roof trusses. And the microfactory integrates all of those elements into just one into the one microfactory. So you no longer need all those different production lines. And there's some really smart things that happen in the microfactory. So one is that one of the constraints that we had is that it needed to be able to be used by someone with no robotics expertise and very kind of like low threshold in terms of skills required as a result, which means that we need to be able to bake into the microfactory a degree of like no need for like adjusting in real time to like human fallibility. So you can see here on the left, there's 2 stacks of wood. One is timber lengths, one is OSB sheets, and they are brought into the microfactory area, but they don't need to be placed precisely within within the microfactory itself, which means that the microfactory has the capacity to understand where that has been placed and adapt its programming in real time to where it's been placed. So essentially what the robot is doing at this point is it's scanned where those stacks are located, and then it adapts its program to understand what is the first piece that it needs to pick up. And then in the front there, you can see a cutting machine that we've adapted so you get pure manufactured material in straight from the manufacturer with no pre-cutting needed. And then the machine will adapt the pieces that are needed. It will cut them to size, and it will store the extra material for later in the robot program, which means that it has a memory attached to it as well, so that there's zero waste or very minimal waste, like 1% material waste overall. There's also a couple of other smart things that happen within the microfactory on the assembly table. The end effector for the robot, which is essentially what we call like a Swiss knife, has the ability to grip in multiple directions, has the ability to pick and place material, it has the ability to vacuum material, and it also has the ability to nail material. And so it will calibrate the position of the material in real time. You can see some of the material being moved into the correct position in order to create an ultimately like completely precise element. And then it will pick up that last sheet and nail it into place as well as nudge it into place. So there's no need for manual human intervention once it comes off of the assembly table as well. So all together, the robot arm, the end effector, the assembly table, and the cutting machine makes one complete robotic system that requires no human intervention except for bringing material in and taking material out, and essentially can work for as long as there's a stack of material in place, again, without that human intervention. And what this means for our customers right now is that one microfactory can produce the floors, walls, ceilings, and roofs for 120 homes a year. It can produce one house in one day, and it requires one operator for less than 2 hours of one shift, which means that one operator can operate 4 to 5 microfactories at any one time. We currently have a 12-week lead time from the moment that a customer places an order for a microfactory to the point that it's delivered and ready for production. And then in terms of our timber frame approach, we're able to guarantee up to a 70% reduction in manufactured cost of the timber frame panel itself. And when you look at the overall building cost, the pie that makes up a building, we address right now 20% of the building cost directly, but we have ripple effects across up to 60% of the building costs because of the way that we engineer assembly sequencing, time on site, et cetera. Also with the platform at the moment, we have designed it for EU and US building codes, which means that essentially the platform acts as a kind of API for timber frame construction across those geographies. And at large, what that means in terms of CO2 emissions, that we're currently hitting over 40% lower CO2 than the EU targets. And in the EU, the strictest carbon target is in Denmark, and we're 47% lower than the Denmark baseline target. So Master Builder provides this essential full chain design to manufacturing workflow. It provides upfront pricing, sequencing, and bills of materials, and it has that integrated structural engineering baked in as well. So we see this as a very scalable business model for distributed robotic manufacturing and construction. The way that we get it out to our customers is through a hardware as a service or a HaaS-based partnership, which means that we charge a monthly fee for support and remote operation of the microfactory, essentially producing the manufacturing data that's needed by our customers, and then a usage fee, which is variable per square meter or per square foot. And we're selling these microfactories in deals from a small number, one microfactory, to up to 100 per deal. But on average, our customers are looking to have around 5 to 10 microfactories per customer. And where we're targeting this right now is in home builders with kind of a minimum of 20 million in turnover, which means that they're doing around 500 to 1,000 homes a year. So they're regional builders that are really feeling the pinch in terms of the logistics around timber construction. And what that means for us is that an average annual total contract value per microfactory per customer is around 670,000 pounds if it operates 50% of the time. So just to give you a little bit of insight of what that means for our business, if you are able to produce 120 homes with one microfactory, which equates to about 44,000 square meters of timber frame a year, we get that annual revenue. We're on average using per customer 5 microfactories, which means that we need about 75 customers to do about 210 million in annual revenue with a pretty significant gross margin that looks like we're hitting around software as a service-based margins, but with a hardware business. When you look more closely at the microfactory itself, so we see the microfactory lasting about 10 years. On average, we're deploying it twice over that time. We ask each customer to pay a setup fee of around 100,000 pounds. And essentially what we've been able to achieve in terms of the expense to us is that the hardware for one microfactory costs 100,000 pounds. The robot itself costs around 50,000 pounds, but we lease that from a third party, so it's a very minimal cost to us, and it costs us about 25,000 pounds to deploy just one microfactory over its lifetime. One of the important things that we do with our customers is develop business cases, which has a series of different assumptions baked into it. So one of those assumptions as a baseline is that our customers will run an 8-hour shift. In reality, they run around 12-hour shifts. But we also bake in that across that they'll use one microfactory at a maximum of about 80% of the time across that 8-hour shift, that we need about less than 2 hours from one operator, that we're working 230 days a year, and we directly input into the business case the square meter material cost directly from Master Builder. And the outcome of that is that one customer can create a 44,000 square meter production capacity for 120 homes a year, and they can reduce their FTE in terms of that production by up to 96%, which means in terms of the business case that for every £1 they spend with us, they make 270 pounds back, and that creates a 2.6 million ROI for them each year, which is, as you can probably imagine, linked to the earlier statement that I made around cost benefits. It's quite a significant cost benefit that allows our customers to really expand their business capacity or expand into other regions. So we believe that this is a pretty interesting game when you think about how the large modular factories like LNG on the far right has been set up, where it required over 50 million in capex, had a 4,000 homes a year capacity. It actually only delivered about 400 homes a year before it was shut down, and it had zero customer ROI. For the same amount of money in terms of setup fees with our customers, they can achieve 60,000 homes a year with 1.7 billion pound ROI. So it's quite a significant game change in terms of transforming the economics of home building. What we're moving to is AUAR as being the enabler of a large distributed factory network. We're moving towards a containerized version of the microfactory, where essentially that microfactory fits into a 20-foot shipping container. And we've explored this a little bit. I'll show some images later of how we've done this previously with our customers already. We've been really active over the last couple of years. So we, in 2024, signed 4 customers. We did about $1 million in revenue. We had about, at the end of 2024, about 60 customers in our sales pipeline. This year, we're projected to just over 3 times that, with now 10 new customers rather than 5, and we're expanding pretty rapidly up to about 50 customers over the next couple of years. This is just a repeat slide, sorry. And so really our proposition is that we essentially are that design to manufacturing replacement for home builders, where we're able to develop product homes with robotic manufacturing with Master Builder and our microfactories. Right now, we're able to enable our customers to deliver 1 to 3 stories, single family and multifamily, 4 stories in the US actually. And then we're moving very rapidly to being able to offer up to 6 to 8 stories, depending on the market. We want to Innovate UK, which is the government agency for innovation, a couple of months ago to fast track that development this year. Whereas we previously had anticipated we would only be able to start offering 6 to 8 stories mid-rise multifamily in 2026. We'll be able to offer it by the end of this year. So the power behind AUAR is really our approach to our building system. So we are able to produce open panels for floors, walls, and roofs, which are flexible, circular, and low cost, so they can be adapted to any design constraints and adapted to our local supply chain. And essentially what that means is that we are essentially using some of the intelligence behind Master Builder to develop assembly sequences and full timber panels that have openings embedded already in them, which if you have any experience in timber panel construction is something that's quite a unique differentiator that AUAR provides. And essentially what that means is that we've developed our building system entirely in GitHub. This is actually a very old image. So it's now become really a codified version of timber frame construction that can be deployed anywhere across Europe and North America. So it's just some of the standard details. Essentially what we create is code, but it gets deployed as readable drawings that are normative for the industry. I'll tell you about this project a little bit later, but one of our kind of secret sauces in AUAR is that we can deliver the entire home, but we can also deliver non-load-bearing exterior wall panels as well. This is a project that we did in Belgium. I'll show you a little bit about this later on. And then we've recently finished an LCA for a template AUAR 3-bedroom house. Excuse me, which shows that we are essentially a carbon sink in each home that we build, where each home sinks 12 metric tons of CO2 just in the timber frame alone. One of the ways that we're scaling to 6 stories mid-rise is through hybrid glulam timber frames. This is a project that we delivered end of last year, where essentially we used a one-directional glulam structural system that cuts down on the need for engineered woods, but provides the structural stability as a hybrid system between the glulam and the timber frame panels that the microfactory produces. I'll just skip that. We've moved pretty fast over the last now 14 months. So on the far left was the first microfactory that we developed in September 2023. We pretty rapidly moved on from that microfactory. It's now just like a monument in our space in London. It literally sits like that now. And you can see here that like the end effector, even the Swiss Army knife at the end is really not a Swiss Army knife at that point. It was just one gripper that could only grip in one direction. We moved that towards V1 in January 2024, which required that we had pre-cut wood put onto a physical shelf. In the microfactory at that point, we were still using also glue as part of this process. And then in January 2024, we deployed, or in September 2024, we deployed our latest version, V2, which we also shipped out beyond. We built 4 and we shipped out 3 to customers. So you can see here that original version, which essentially you take that operator was required to stack the physical shelf. It then calibrated the position of the wood. It had only 1 nail gun at the time as well, and the glue process and a very small assembly table. So at the moment in this configuration, it could only do wall panels that were 60 meters by 2.4 meters long. And we're now able to do a much larger panel that comes out of the microfactory itself. With that first microfactory version, we delivered an interior fit-out project for a tech hub in Ghent in Belgium. And this was really just to validate the performance metrics around the microfactory itself. We then iterated to a much larger structure. So this was all of the panels that were produced for a 2-story house prototype that's being used as a warehouse office by our partners in Belgium, and was delivered on site with that hybrid glulam one-directional system in September of 2024. And it was built on site by 2 guys that had no expertise in timber, had actually never worked with timber before, in less than 5 days, with quite a lot of tricky things that we forced them to deal with. So, for example, you can see here that there's different sizes of windows. Those windows are offset. On the side of the building on the right, which you can't see here, there was also a window that went across 2 stories. So we tried to make our lives difficult in some ways as well to demonstrate that we could get that variability in what came out of the microfactory. You can see here that like 2-story transgressing window. So V2 became a much more complex machine in terms of its how it was a robotic system. So again, it has a ability to shoot nails in 2 different directions, has an ability to pick up sheet material, and it has an ability to grab material from 3 directions. And what that means is that we can now produce timber frame panels that are 1.2 meters wide by 4.8 meters long, which means we can do an entire floor slab for a typical house. Excuse me. And one of the things that we're examining now is just how big does that assembly table get? So we're looking at it as though it's very likely to double in vertical height, but stay the same width as 4.8 meters, which means we can do entire walls rather than slices. This is just that microfactory being set up with one of our automation partners, ABV Robotics. They're in their UK headquarters, but they're a global company. And then we shipped off 2 of those, just like this, to the US in September of 2024. And they're being installed now. My team's actually flying out this week to do the installation and go into production pretty rapidly in April. We're moving now towards this containerized version, essentially where you set up the microfactory with we calibrate the microfactory before it gets set out, which reduces our overheads and OpEx expenses in setting it up, and means that we can really like pop up almost anywhere with the microfactory itself. One of the important things here is that we can have real-time simulation, so we can real-time adapt the designs as needed and change the production cycle as well, and have very like clear instructions for the operator of what they need to do, which means that they don't require any robotics expertise in order to operate it. And one of the important things here is that we've simulated this entire process so that we're ahead of the targets for what most timber frame manufacturers would be produced in terms of the square meter speed per week. I'm going to skip that. Another fun thing that we are constantly working on is trying to find like what is the ideal panel size for the vast majority of the homes that we're developing. So we did a kind of massive analysis of 20,000 different kinds of walls and the cost metrics attached to them last summer, where we were able to essentially find this like really happy middle section of walls that are used in 80% of all the homes that our microfactory is producing. This, for example, is what our business case calculator looks like. You can see the yellow boxes there are us being able to help our customers understand that what does it mean to operate multiple robot cells, change the operating hours per shift of the day, and also target the sales price with them as well so that they can understand their ROI. One of the things here is that because a master builder is directly connected to the building code requirements for a specific market, we're able to simulate down to the very nail the position of all of the parts and components that go into a timber frame panel as well. Oh, it's master builder again. And then also importantly here, we've linked that database with really any Revit project, and we can blockify what we call essentially that translation into manufacturing data just with one click rather than requiring a user to kind of go through and do any custom coding. Some of the typology variations that we've worked on, you can see here. So we are doing everything from single family homes to larger developments, row houses, whatnot. And then also doing some of the structural analysis that's needed in the sizing. One of the important things that we've done with Wall Builder is that we had a partnership with Google Cloud in the middle of last year, where essentially what we did was we used prompt engineering to have an AI learn from the JSON files that are produced in Master Builder so that it can automatically produce homes using natural language programming, essentially meaning that if you say, I need a wall that's 1,800 millimeters long with a single opening, this is where it needs to be spaced, it will automatically produce that as well, which means that we've had quite significant milestones in being able to make this an AI-ready platform so that we can automatically generate with AI the generation of all the components that are needed in a wall and make them ready for fabrication. We can also automatically generate all the instructions that are ready for the robot to consume, and from that we can extract all the quantities within a design as well. What that is leading us to is that we've done the lower left already, where we can automate requirements gathering to generate the elements within a house. We're moving very rapidly this year to being able to automate the requirements gathering for generating entire designs. That will move us towards generating the layouts and variations on those layouts, and then link it back to our generative manufacturing platform. So these are three kind of template homes that we've developed within the platform itself that are fully costed and can be adapted by our customers to their specific site and their specific budget. We've done that with a 260 home project last year in Belgium, where there was some existing ex-army barracks, but 260 homes in both single-family houses as well as low-rise apartment buildings. We essentially gave the architects that we worked with three architectural practices on this project, a set of design parameters, and asked them to make a variety of typologies, which you can see on the right-hand side of that image there. And it's kind of great Cambrian array of everything that they produced there. And what's unique, I think, in our approach is that, we're agnostic to how a building appears in the world. We have our own aesthetic that we like for sure, but ultimately, in order to really solve the housing crisis, you need to be able to be entirely localized, which means you need to be agnostic to how a building is finished. So in this case, there was a brick finish on this duplex type. And then the low-rise apartment, you can see, again, a kind of more typical, how you would see a more typical low-rise apartment. And then the single-family houses also having a kind of timber finish. And what's important here in terms of what we were able to achieve as a construction team is about 30 to 40% lower square meter cost than what you would typically get in the market. And I think what's interesting about this image is that the underlying system behind them is exactly the same. It's just the way that they appear in the world is very, very different. And this is the cost down to door handles and the greatest detail that you can get, basically. We're pretty aggressively working on developing pipeline with our partners. So this is a project with a developer and our microfactory partner in Belgium that we're working on. We're also working with a sustainable developer in the UK for 175 homes. We've also done some development for a social housing bid in Belgium, which once we've won the bid to be on the procurement platform, we'll be able to deliver those homes across a specific area of Belgium with our partners there. This is a small ADU that we developed for our partners in America, in Indiana, which is able to be stretched and adapted to be either a single-story ADU, a two-story ADU, or a much larger single-family house as well. And out of everything that we did in the second half of 2024, these are all the different types of building types that came out of Master Builder. One of the things that we also did we're about to have a really big press release come out on this project, but this is an external facade project I mentioned earlier for KU Leuven, which is a university in Belgium that has won EU funding to set up a circular construction hub. And part of that is the adaptation of an existing precast concrete and steel structure into the main hub of that project, which is called Constructor. And we delivered the closed wall panels for that project in December, and it's being completed now. This is a project we're working on with a developer and our microfactory partner in Brussels, which is basically an entire city block just of the external facade panels, similar to this project. And then in the UK, we're working with two developers, one of which is the developer I mentioned earlier with the 175 homes called Town. We've also partnered with Bywater, which is backed by Sumitomo Forestry, and they have a £4 billion remit to invest in sustainable timber homes across Europe. And part of that is a partnership with Donaldson Timber Systems, which is the largest timber frame producer in the UK. They do about 10,000 homes a year for the home builders out here. We've also partnered with one of the largest developer builders, like integrated home builders in the Nordics. And we are delivering a microfactory to them in May, first doing wall panels by the end of this year for a couple of different projects, and then graduating to a single family house, and then towards mid-rise in mid-2026. And we're also like rapidly signing customers across the states. So this is just some examples of some of the typologies that we're working on with those partners down in the lower right-hand corner, from single family homes to entire neighborhoods. And so, yeah, we're really busy at the moment. So we're adding 10 microfactories this year. We're lining up 25 more commitments. We had a really busy end of 2024 where we did a couple of strategic press releases, and that created a kind of 25 times growth opportunity. And one of the strategic things that we've done over the course of the last couple of years at AUAR is we've gotten on board a couple of strategic growth partners. So one of those is ABB Robotics, one of the largest robotic arm manufacturers globally. They've actually been our automation partner since 2021. We had our very first test factory with them in their UK headquarters in 2022, and now we work with them really closely on deployment in the US. We also have a partnership with Holcim, one with Sika, and we're part of this group in Europe called Built by Nature, which is supporting the advancement of timber construction across Europe. So yeah, we interestingly are starting to kind of separate out the services that we provide. Of course, the core one for us is the kind of HaaS service model, which is the full value chain integration from design to manufacturing. But we're also separating out to customers. Design services is one side of something that we offer to a customer, as well as manufacturing services, or a mix of design and manufacturing, but maybe not the full entire stack. And so, yeah, I'm super happy to be here. I'm really happy to answer loads of questions. And thanks for having me.
Thank you, Molly. Awesome presentation. Everybody here is clearly pretty fascinated. I'm going to start because I can. Clearly, if you're doing work in Belgium, a lot of this work is passive house. Clearly, you're massing, and when wall ratios speak to passive house, it's hard to tell from your details continuous insulation on the exterior. I thought I saw something about Styco. What's your go-to wall section? Are they 2x6? Are they 2x8? Are you relying on optimized framing and all insulation in the frame, or is there CI as well?
No, all insulation is in the frame. And ultimately, like, our baseline is a passive house standard home, which means a thicker wall, right? But what we offer is the full spectrum. So you can do a super thick wall, with like the strategy that some of our customers have is that they want to have like zero bill homes, right? So they want to have something that's totally passive. And so it really depends on what the customer ultimately wants to do. One of the things around insulation for us is that we have to be agnostic in a way, but we tend to try and push our position towards insulation towards our customers. So one of those debates that we had recently was like a customer wanted to just put in polyurethane. And we were like, come on, like it's 2025. We don't need to put polyurethane into buildings anymore. There's so many other better solutions out there. And they said, well, it's cheaper to do it. And we said, let's show you that it's not. And essentially, we were able to demonstrate to them that using cellulose was cheaper with us than it would be to put in polyurethane. And obviously, the longevity of it is much better and the performance of it is much better. So we do a lot of education work with our customers. I think that's something that like I have a lot of experience doing from my earlier career in research and academia, is filling that education gap. And it's something that we work on pretty actively with the people that we work with. And it's part of our sales appraisal process as well, as kind of doing that convincing process. But ultimately, if it is better on cost, people go for it.
building on what Robin, you mentioned that you can tune this to different building requirements and building codes depending on working. What's that process? As I noted, a lot of the examples that you included were very prescriptive with like double top plates and other requirements. Is there ability to tune that not just to the local building codes, but also to choosing like advanced framing methods in order to reduce the total amount of framing?
Yeah, so we have the most experience in Europe, which is a little bit different than how the US operates. In Europe, there's a Euro code specifically for timber frame, which is Euro code 6, and it's the same everywhere across Europe. And so we essentially onboarded Master Builder into a full Eurocode setup so that it can be deployed anywhere. And therefore, our building system approach is quite smart. Like we are trying to reduce the amount of material. We're trying to optimize where material is used in relationship to both cost and structural integrity. So we're constantly trying to find the best possible solution and optimize as much as possible in terms of the framing that's there. And so there are some weird things that happen in Master Builder around lintels, for example, and sills, where we essentially are like, does it need to be used and how sized does it need to be in order to make it meet those kind of metrics? So there will sometimes be what might look like an anomaly to an expert in a normal sense, but for us, actually, it makes a lot of sense for how the building system's been developed.
Jason Hasko, and Brett's colleague is next in queue. Jason, if you want to unmute yourself, you can ask a question or I can do it for you.
Yeah, hi. Thanks, Molly, for a great presentation. So I was just curious on the tech side of things, how big your computer development team is and kind of how long they've been working at that end of things. And in the same vein, kind of have you looked into any blockchain opportunities in your ecosystem, smart contracts and things like that?
Yeah, so I have a team of 4 software developers.
Cool.
So 3 of them have worked with me well, 2 of them have worked with me since the beginning of AUAR. So AUAR was started in 2019 as a consultancy, and actually 2 of them were interns when they started with us. And they led our consultancy work in software development. We did a lot of work for large multinationals, developing design to manufacturing workflows using generative design for like the likes of IKEA and others. And so we essentially trained them through that consultancy work, which means that we learned a lot about what not to do in terms of software development, like from the ground up. Like we worked on projects where you had like total solutions and like really closed software packages that were being developed. And so we developed a very like opposite approach. We only very recently added a 4th person to the team, and she's specifically working on the connection between Master Builder and streaming that data to the robot. And so yeah, we're just 4. It's a pretty nimble team. We actually only put our full 4 team resources into Master Builder. We had a bunch of different code setups pre 2024, but we've really only been working on Master Builder properly for about a year.
Cool.
And then on blockchain, like sure. Like I'm interested. I 100% am like a decentralized thinker, and that's what I'm interested in. But for us, it's not something that we're actively exploring at the moment. It is something that our customers are actively exploring, and we see opportunities for integration.
Cool. Thank you.
Mm-hmm.
Is the Master Builder program starting to integrate like lift points within these panels, or is that just being left entirely to the builder?
No, we are integrating lift points. So in Constructor, that exterior facade project, we were able to pre-design all of the lift points for the panels. What we don't have within the microfactory is a router capacity right now. So that was done manually after the panels were created outside of the walls of the microfactory itself. But it is something that we've done before. We just took it out of this last commercialized version. It's being integrated again into the next version that we'll have later this year. It's up until now, it wasn't actually the biggest value add for us in terms of like reducing labor costs, but we can do it in the design side.
We just looked at another presentation that's coming up later in our season where they were using the lift point holes as locator or shear pin holes for a dead loaded design, which I thought was pretty cool. So we're gonna make the whole nice working account.
Mhm.
As follow-up to Philippe's question, can you speak a little bit about like where ours scope ends and how you guys manage the transition from the stuff you've produced to the installation? You're giving them a roadmap. Are you also talking about sequencing? I mean, how are you helping them take all of this produced material and then turn that into a building? Like what?
Yeah, so Master Builder produces full assembly sequencing based on the customer requirements. So there's three ways of thinking about it. So there's kind of three general methods of delivery, right? One is panel by panel, one is larger panel, and one is volumetric. We have found, generally speaking, that customers don't want to do volumetric, and that panelized is, generally speaking, the way our customers want to move or are comfortable working in. So Master Builder is developed specifically around a small panel and large panel assembly. And so all of that sequencing is taken care of, and we produce the kind of data sets for that. So what's interesting is that the way that we deploy into customers is we work with their architecture teams. We don't take on the responsibility of we don't take on the architect's responsibility. We don't take on the builder's responsibility anyway, but we provide the data for them to make the right decisions in order to do that.
Very cool. Thank you.
So with design responsibility, it sounds like Master Builder is doing the engineering and analysis. Who's checking that or taking on?
It's doing pre-calcs. So it's doing pre-calcs, and then we still need a local engineer to sign off. And it's the same thing with the architecture.
So do you provide like the engineered drawings, and then it's up to the design professional to review those drawings and stamp them?
Yep. So, and then one of the ways that we circumnavigate having to do that again and again and again is that once we provide something that's pre-calced, once it's fully engineered, it can always exist on the platform, which means that the next time that it's built, it doesn't have to go through the full process again. So it reduces the long-term costs of deploying a product on the platform over and over.
Have you thought of scaling this further? Like right now, you're just making wood panels, studs and sheathing. What's the next step that you see taking beyond that?
So we're doing floors, walls, and roofs. And we can do like simple cassette pitched roofs right now. And we're looking at like how complex a roof do we need to be able to do? The reality is that there's always going to be a case for a roof truss, particularly in the North American market to a certain degree. So it's like, do we actually want to be able to automate that as a solution, or is it actually much better done elsewhere? But the idea is that essentially you've reduced the production needs down for like most of the structure down to the one capacity of the one microfactory.
I guess I was thinking like other materials like insulation.
Oh, other materials. Yeah, so we always like our biggest challenge in terms of an automation problem was being able to deliver floors, walls, roofs, right? The second one is like, what's the next low-hanging fruit? The first thing is like routing holes. Like that is like a very low-hanging fruit for us, is adding in a router to that Swiss Army knife on the end effector. The third one is like, okay, yeah, insulation could be it. But again, we're trying to move our customers away from sheet insulation, and in reality, actually the labor cost around that is very minimal. So it can happen just outside of the cell. One of the adaptations that we're looking at making around the assembly table is that instead of the robot having to pick that panel off and place it on a stack, is actually have the assembly table roll out of the microfactory itself onto a table where that additional work can be done more easily. But TBC.
What's your maximum panel size at this point? Clearly,
Right now, it's as of today, it's 1.2 by 4.8 meters.
4.2.
You got a question, Tom?
Yeah.
Yeah, I was thinking about it. I guess picking up on on what Luke was asking about earlier. You know, and just thinking in the context of project delivery methods in the US, let's say it's design bid build or even design assist. I'm trying to get a sense of where you all would plug in relative to the architect's work. Is there model exchange? I mean, ultimately, the architects and the relevant engineers, as you were saying, you know, need to, you know, certainly check, also integrate what comes out of your software into our documents that ultimately are submitted to authorities having jurisdiction for building permit, et cetera. And I'm just curious if you could speak more about how or what your relationship is in that mix, or what it ideally would be for you all.
Yeah, so there's two ways that we look at it. One is that we can replace a lot of the architect's work.
Oh, fantastic.
Yeah. I mean, we're architects, right? So we
Right.
love architecting. We're trying to resist the urge to do that too much because as a business, it's difficult to scale it as it stands doing that, right? We're a venture-backed business, so we have to kind of play the game around that. But what's interesting in the US with the architects that we're working with our home builder partner is that we essentially worked with them on the concept design and then we took everything over up until the moment that construction documents were being produced. And in actuality, we did produce quite a lot of the construction documents already through Master Builder. And so we, in a way, it's interesting because we're very much working with values aligned companies on this that are interested in this as a model, as a way to prove out that it works, rather than saying that this will work for everyone in terms of what they want to own and what they don't want to own. And so we've done a lot of work in terms of approaching the right kinds of firms to work with on the development side of what we're doing.
And it seems like your target market is those home builders that build at scale, which are sort of a different market from the ones that we as architects, you know, focus on, which are sort of one-off projects or have limited scalability, I guess.
Yeah.
Um, and so maybe that's a welcome development, actually, certainly in the context of the U.S. home building market.
Yeah, 100%. I mean, ultimately, we're working with home builders that have their own in-house design team. The way that we've operated so far in the US is that we were working with essentially like our partner there is their top co is a holding company for businesses across the supply chain. So they have truss manufacturers, timber panel manufacturers, lumber companies, development companies, a home builder. And they themselves purchased a home builder to work directly with us. But in order to catalyze the relationship, we developed a product with an outside architecture practice. Essentially, that practice will receive a royalty
Yeah,
from working with us for as long as that product is built.
got it.
Yeah, just to follow up on that, like, I think it's pretty clear what your value add is to the, GCs and developers and these large scale home builders in terms of, streamlining the whole design and pricing and procurement and construction process. But like, to put yourselves in the shoes of a practicing architect who maybe that's not what they do every day, is there a model where they could take advantage of your technology and the efficiencies that AUAR brings to the table, and still be able to have their sort of design expertise inform that? What you just alluded to with the partnership and the royalties, that's a great example. Like, is that something you guys are focusing on, or are you really focusing more on these larger developers and trying to streamline their processes?
Yeah, I mean, so the relationship with architecture practices was a way in for us. but it's not ultimately the end game, but there's still a massive benefit. So that's one of the things I alluded to at the end of the presentation, was that we are now creating different kind of channels for revenue. And one of those is around architects being able to work with some parameters that means that they benefit from utilizing the platform. So for example, they are given a set of design parameters. And those design parameters are really just based on like common sense, right? And what they get back is a fully costed project. So they can really truly understand the consequences of the design decisions that they're making, and that there's a real back and forth with real numbers and real predictability in that and real repeatability of that. So once you work with us once, you really understand how you can work with us more and begin to scale that. And then you benefit from something being deployed through the platform in terms of the royalty. So it creates this kind of like collusion between us and architecture practices that we think is really exciting. And ultimately, like, we don't care how a building appears in the world. That's for an art, like for whoever of our customers to be able to instrumentalize for themselves. We obviously have our own design aesthetic, but ultimately that's not how we're going to solve any of the problems that we see if we hold on to that too hard.
We are coming up on 5:30, so to be respectful of everybody's time and Molly's bedtime in the UK, if anybody has any last minute questions, or we're also always happy to hang out as long as our presenter is happy to hang out. But
Yeah, I can stay for 5. It's all good if there's more questions.
Oh, I got lots of questions, but, is there a way to adjust the, deflection tolerances on the floors, say if you want a really stiff floor? Real-time design, sounds like, yeah, that was an easy one. What about integrated, sizing for like, a custom window package, right? You have stock transition details are automatically adjusted parametrically with the aperture opening, and then I mean, the synergies are just tripping over themselves in my mind, so it's just like.
Yeah. So we've done, we essentially developed like a window-based panel that allows us to create variability with it to adapt to that exact problem. We've done it successfully in Europe, where the constraints are more universal in a way, and kind of resolve some of the problems that you see around like how windows are delivered and the kind of process, like, which is so arcane, as you'll probably know, like how windows are sized and installed and all these things, like insane. So we've done that successfully here. It is something that we don't have fully automated at this point, but we can do some adaptation in real time.
Right, but if it's all parametrically driven, you can actually get the down custom sill depths.
Yep.
So they'll actually show up in order.
Yeah. So we already do custom size, like we already do variable sizing within Master Builder, just up to a certain limit.
And talking about the licensing, I just had a quick question. Obviously, in the US market, there's just a wide variety in code requirements and licensing. So state by state, and engineers are going to be licensed. But you were mentioning that once you've completed a design, it's hosted on the platform, it can be reused with some royalties to whoever that is. How is that being approached with the fact that that engineering stamp only applies by state?
Yeah, I mean, we're working with builders that are generally working within a state at this point. We're obviously seeing some movement towards our US partner currently, for example, wanting to take over more of the Midwest, and then we'll go through that process when it happens. And one of the ways that we're coping with that is by having partnership with engineering firms that operate across multiple states rather than just one. So the builder themselves might only operate in one place, but the engineers and the architecture practices that we're working with are qualified in other places too.
What are some of your hopes and dreams for the next year?
More homes built would be great. Yeah, I mean, our plans for this year, so like we had a really insane end of 2024. Beyond my expectation, we doubled what we thought we were going to deploy this year as a result. So we went from at the end, going away for Christmas, thinking we'd deploy 5 microfactories this year. We're now doing 10. We have 40% of that called for already. And that's unlocking that is mainly just my time, to be honest, is the blocker. I just completed a fundraise, well, not fully completed. I'm in the legal negotiations for a fundraise right now, which will unlock my time again. So for me, it's getting those 10 microfactories deployed, containerizing fully the microfactory itself, and really building out the operational capacity within an hour to deliver at scale. We're very R&D intensive business, and we need to split out that capacity across our current team and really resource it properly, because right now it's driving the car while building the car.
So, provided you are able to unlock your time and probably clone yourself, your growth plan in the US look like? Are you just have this single partner, and is that exclusive, or?
No, there's no exclusivity. So this first partner will be operational in April, and we're using that first partner as a part of our sales and go-to-market in the US. So they have a big vision to be our distribution partner in a large swath of the US. That is reliant on them meeting milestones around building homes, and proving that they have a capacity to deliver where they're located to begin with, and then potentially gain exclusivity through meeting those milestones on distribution. But we have a bunch of other conversations on in the US. The important thing for us is that we're not US based. We have no team in the US right now. And so we actually have to do the hiring to get the team there in time for that microfactory to go live, so we can actually like use that as a catalyst for the sales that we have lined up. Which means that we need something built, microfactory in production, so people can come and touch it, smell it, see it, all the things that are important in convincing people that that the sale makes sense, which is how we've done it in Europe already, and it's been super successful. So yeah, moving towards a large scale move in the US in 2026.
So on that note, where geographically is your first stepping stone?
In Indiana.
India, okay.
So you may or may not remember from 20 years ago, I've always been kind of interested in shipping containers as a ubiquitous multimodal thing, right? Like they just make sense, they're not going anywhere. Can you tell me a little bit about this newest iteration of your product where, you know, when it shows up in a shipping container, it's not just using that shipping container as a mode of transportation, like is it actually going to be able to deploy, function, and then redeploy? What does that process look like? Are you packing, unpacking, repacking, or is it literally like deploying? Like I'm fascinated by like the lifting roof, the folding wall. You know, is that something you guys have pretty well resolved? And is the intention for this thing to be able to just like close back up, move, and redeploy?
Yeah, exactly that. So the biggest operational challenge for us is installation, whatever that means. It's very intensive on us right now. Like I have to send 4 people out to the US to do this install for the 2 microfactories, and they have to be there for like basically 2 months on and off. It's also meant that our partners have to have certain specs, right? Like certain depth of concrete, certain reinforcement, like all the things you can imagine, because the robot is a industrial machine that has a big payload and does a lot of fast movements, and it needs to be well secured to the floor. This has been very challenging. It wasn't so much a challenge for us in Europe because we had more ownership over those locations. Like the Belgian microfactory that we have is an asset managed by us in a partner's facility. And so we've been able to cut corners, right? Like where we feel comfortable cutting corners. We can't do that at scale. It's really stupid. And so containerizing actually offers us a myriad of solutions, which means that we can install the robot on a steel base, be able to secure it to the ground once it delivers, and then essentially have like much less calibration that's needed, and all the installation happens on our end rather than on the customer's end.
Yeah, that's going to be quite the game changer for you guys.
Yeah, the biggest challenge from what I can understand in the American context, it's not so much a problem in Europe because of how dense it already is in terms of utilities. Is actually the electrical needed to power the microfactory is the biggest challenge that we're going to face. So we've actually done 0 electrical engineering on the microfactory so far, and we're really like yeah, following kind of the things that our automation partner specs, but we have a big opportunity in terms of making it more efficient in terms of electricals to be able to confront that problem.
So is it 220 or three-phase?
It's three-phase, and parts of it needs 400-volt.
I have another quick question. Earlier on in the presentation, you mentioned there was a cutoff maybe of 3 or 4 stories in the US. And does that have something to do with the transition from type 5 to type 3A or B construction? And if so, like what's the kind of barrier and how are you confronting it?
Yeah, it has to do with that. And then the main thing for us is that over a certain height, you come into all the problems around fire regulation, right? In Europe, this is like a mega bottleneck in terms of design engineering. We've pretty much confronted it with the house that we did last year, because we used the glulam system to deal with a lot of those problems. And we believe that it's replicable in the US, but again, we're still like confronting what that means. But like it's also a lot easier to build out of timber in the US in comparison to Europe. It's actually really hard to do what we're doing here with the regulatory environment. So yeah, it has to do a lot with the fire regs and the acoustic needs and things like that that we're confronting in terms of going higher. Which
Got
is
it.
why we need a hybrid system of some kind.
Well, I know it's pretty late where you're at. I just want to thank you so much for taking your time at this hour. I'm away from this very amazing business that you're building and running. Thank you so much.
No problem. Thanks for having me. Appreciate it. Have
Thanks
a
a
good
lot.
rest of your day.